Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we are talking about SSTO vehicles. Hey, Ben, how are you?
Hey Simon, how's it going? Hi, fellow Econauts. Yes, today we want to talk about SSTO vehicles.
That brings me to my first question. What is a SSTO vehicle?
SSTO is an abbreviation, obviously, and stands for Single Stage to Orbit, SSTO. So it's a vehicle other than often rockets when they need stage one, stage two, and so on. They can reach orbit with one stage, and then often also, depending on the definition, are reusable.
And do we have any example for that?
If you take out the reusability, then there are some light rockets which can reach orbit with one stage, often solid. So the fuel is often solid in the rocket body and burns. So therefore, the most of the rocket doesn't really come back because it burns. But depending on the definition, if you take into account the reusability, then we have no SSTO vehicle as of now.
Is there a reason for that? I know the answer, but I have to ask a question anyway.
Yes, there's a reason, and that's it's called the tyranny of the rocket equation. In order to reach orbit with a chemical propulsion, you have to overcome friction, gravitation. You have to get to the speed that you fall over the horizon, and so on. In order to overcome the gravitation of Earth, you need 90% of the rocket weight will be fuel. So, in other words, if your rocket weighs 1 ton, then you need this times 10 in fuel to reach orbit. And then that's just to reach orbit. Anything extra requires more fuel. So, and because that the tank to contain the fuel is heavy in itself, that's usually the stages, and you want to get rid of them so that the spacecraft itself is not as heavy anymore. So that's the main reason why we don't have SSTO vehicles currently, because the chemical propulsion we're using is quite unfeasible for SSTO vehicles. There are some attempts in history, and even SpaceX Starship was sort of, maybe they had the wish to make this an SSTO vehicle. The actual spacecraft itself sort of is, but still needs the heavy launch to get pushed into orbit, and then can be reused and land and so on. But until then, it's not an SSTO.
Let's say, and obviously I'm not the rocket scientist. That's the reason why you're on the show, right?
Well,
but
that's
but
no
let's
rocket science.
but let's say the rocket itself is made out of steel. If we could use something else like aluminum, for example, to make the rocket lighter, would that change anything, or is that still the same problem?
Well, it would definitely reduce a little how much fuel you need, but still times 10. And if you then account for any person on board, which is the payload, let's say, 10% of what from the rocket equation is what you push upwards. Anything extra adds to that 10%, hence adding to the fuel. So if you have one person, let's say with equipment and everything 100 kilogram, and that cannot be 10% of the whole rocket. So maybe let's say it's 5% of your payload, of the extra payload, adding times 20 to the fuel. That fuel has to be contained in a container, which you have to carry with you to have enough fuel. Even if we have the most advanced material, it cannot be that light and structurally sound to endure entry and exit of atmosphere. Because, the faster you travel in atmosphere, the more friction, the more heat shielding you need. Otherwise, it just burns off, right? So, and same thing if you go back. That's why they have these often these ceramic tiles as heat shield to help decelerating the spacecraft when it goes into orbit, when it goes into atmosphere. But that is a lot of heat, and you have to be able to sustain that. And all these materials, they are not light.
What about a different kind of fuel? So we are right now using hydrogen, if I'm not mistaken. hydrogen oxygen mixture, let's say
Yeah.
we have like a different we have different chemicals that would be used. Would that make a difference?
Well, so SpaceX is using methane and oxygen, but in any case, with the conventional chemical propulsion, I would say it is impossible to have a proper SSTO vehicle. That's why we still have these heavy launch vehicles and need them to reach anything further than low Earth orbit.
So we basically have to wait for Starship Voyager to make an appearance. So
Yes, we. I mean, don't forget. Let's say for a second that this is all technically feasible. They have cold fusion, which sort of unlocks all the other technologies because now they have virtually unlimited energy. They have impulse drive as propulsion, which can reach 1/4 of light speed. They have warp speed, which makes it even faster. They all just fueled by the cold fusion. They can teleport, so they don't even have to land on a planet because why expend that energy if you don't have to? And the last thing is they can transform matter, antimatter to matter, and vice versa. And therefore, that's why they have the replicators and so on. No, with these 5 things, yeah, of course, then we can have STOs easily.
so we
Any shuttle, it's like these small
yeah,
shuttles they
the
have to
shuttlecrafts, yeah.
go on a planet. They do this sometimes if they can't transport for interference reasons or whatnot. But for some reason, the space shuttle is safe to land then in these cases. Mostly not, because otherwise it would be very boring to watch Star Trek. Mostly something happens. But yeah, you get the point, right? So yeah, so not with chemical propulsion, but if we have a futuristic propulsion available, such as impulse drive or whatnot, it might be.
I know that there are different channels on YouTube that are actually, looking at the science of Star Trek, and it's interesting and also fascinating that some of the stuff is actually feasible, right? I mean, we do not have like access to it, but it is in theory,
Yeah,
theoretical,
theoretically, yeah.
which is like fascinating to me that this can be a thing. But yeah, you already mentioned that cold fusion is basically the first step that we need to crack in order to have like more energy available. And then obviously you have to build something. I would say the space shuttle has already kind of done the second part by
Well, sort
landing,
of, yeah, it could land, but I mean, obviously it
but
was
not
not, it
really.
was too expensive. That's why Starship is more or less born, because,
Absolutely, but
right, so.
if we think about it a little bit, it already had like the second part, not really the first part, because it had to
Yeah.
be connected to a rocket still, right? But it's interesting to think about that this might be possible with cold fusion.
Yeah, and then don't forget, I mean, there are other propulsion systems already available these days, but some of them are not feasible to leave atmosphere. So you could have a solar sail when you're in space, and the solar acceleration from the light can actually propel you quite well. You can have electric propulsion, which already is a thing, which is more efficient, but it is not very strong in comparison with our gravitation. So you can't lift off our planet with us. I think it is all boiling down to energy density. And if any fuel we have, once you burn it, releases a certain amount of energy. And that's where it boils down to. A rocket nozzle is only focusing that energy and guiding that energy in one direction, and hence giving us the propulsion. There are other theoretical propulsion systems available, such as electric propulsion, but also fusion propulsion and anew-tronic fusion propulsion. They might be interesting, but also maybe more interesting for in space. With anew-tronic fusion propulsion, it is theoretically possible to reach like speeds as high as almost the speed of light if you don't stop it with anything. But then we already talked about interstellar travel. There are things in space. It's not just empty, and you need shields.
It is also in the Star Trek universe. that bigger ships are built in space, in the space dock, and also they are only able to actually fly from one celestial body to another, but actually cannot land. On
Yeah.
I think Voyager it's one of the few that can actually do that. But generally speaking, the Enterprise is it's not landing on a planet, right?
There's a reason why they always orbit.
Yes, that's the reason why they're orbiting, because they're too huge. It is like they would not be able to escape gravity again, if I'm not mistaken. So
Yeah.
even with the reason why I bring that up is even with their advanced technology and energy that they have available, they still have like limits, which I think makes Star Trek even more interesting because it
Of course
has
you say
like,
that.
well, sorry, I'm a Star Trek nerd.
That's okay.
That's why I'm so interested in space as well, right? Because I like that show so much. All right, I think maybe we should end it for today. It was definitely very interesting. We had a little chat beforehand, which I thought was like pretty cool as well. If you liked that episode, please don't forget to leave a like and subscribe if you haven't already.
And hit the notification bell. And also, don't forget we have other episodes which you can already watch. And I don't think maybe they're shown here or there. I don't know. Somewhere on our channel.
Somewhere. And also, it would be fantastic if you could leave a comment. We always like reading your comments, and I would like to wish you a good day. Bye bye.
Bye.